Alright, so this video will cover 1633, which says, show how you would convert benzaldehyde into each of the following. You may use any other needed reagents, and more than one step may be required. Alright, so it's a multiple part question. We'll start with part A. We want to convert benzaldehyde to benzyl alcohol, and this can be done with a reducing agent such as sodium borohydride in methanol. And we could also do this with lithium aluminum hydride, but the sodium borohydride is a safer reagent. So part B, we want to convert benzaldehyde to benzylic acid. So here we need an oxidizing agent, and there are, I believe there are several ways we could go about oxidizing this aldehyde to the carboxylic acid. One could be potassium permanganate, as long as we keep it cold, followed by an acidic workup. That we could also do this using a Tollens test reaction with the diamino silver, or silver oxide and hydroxide, followed by an acidic workup. So part C, we want to convert benzaldehyde to this acyl chloride. And so the first step is to convert this aldehyde to the carboxylic acid using either one of these methods here. And so let's just borrow this diamino silver to get that carboxylic acid. Then once we have the carboxylic acid, we can react that with thionyl chloride. To produce the acyl chloride. So part D, you want to convert benzaldehyde to benzophenone, and there's multiple ways we can do this. One is that we could produce the acyl chloride and then do a Friedel-Crafts acylation, or we could do a Grignard reaction. So let's start with the Friedel-Crafts acylation. How would we go about doing that? The first step is we have to convert our benzaldehyde to the acyl chloride, and so we'll borrow this procedure from C. Now we have our acyl chloride. Then we react that acyl chloride with benzene in the presence of aluminum trichloride. And we can get our benzophenone. If we were to use the Grignard reaction, then we would take our benzaldehyde, react that with phenylmagnesium bromide, followed by aqueous acidic workup. We would attach the phenyl group, but we would convert that carbonyl to an alcohol, and so we need to oxidize that alcohol back to the carbonyl, which we can do with PCC. To produce the benzophenone. Now this doesn't have to be PCC. We could get this same oxidation using chromic acid and acetone. So part E, we want to convert benzaldehyde to this alcohol, and we can do this using a Grignard reaction to add this methyl group. So we'll start with methyl magnesium bromide, followed by acidic workup. Convert our carbonyl to an alcohol and add that methyl group. So we can do this just using that Grignard reaction. We should point out that we'll get the enantiomer as well, because this alcohol could point in either direction. So part F, I want to convert benzaldehyde to this molecule. And so again, we can do this using a Grignard reaction. Using this magnesium bromide compound, followed by aqueous acidic workup. We would convert our carbonyl to the alcohol and attach this alkyl group to that carbonyl carbon. So part G, we want to convert benzaldehyde to benzyl bromide. And so the way we go about doing that is to first reduce our benzaldehyde using sodium borohydride and methanol, for example. We convert that to the benzyl alcohol. Then we can react our benzyl alcohol with PBr3 to convert that hydroxyl group to the bromine. So in part H, want to convert benzaldehyde to toluene. So one way of going about this is we can take our benzyl bromide product from part G. So let's begin with that conversion. And then once we have our benzyl bromide, we can react that with lithium aluminum hydride, and that will actually eliminate that halogen and produce the toluene. Another reaction that will convert the alkyl bromide to the alkyl group is zinc in acetic acid. I think other ways of going about this reaction would be the Clemmensen reduction. The Wolff-Kishner reduction, and the Mozingo reduction. So again, that would be the zinc amalgam with hydrochloric acid for the Clemmensen reduction, the hydrazine in basic conditions with heat for the Wolff-Kishner reduction, or the dithiol with catalytic acid followed by Raney nickel hydrogenation for the Mozingo reduction. So I think there are multiple ways to go about converting this benzaldehyde to toluene. So part I, you want to convert benzaldehyde to this dimethyl acetal. We can do that using methanol with catalytic acid such as sulfuric acid to replace this carbonyl with the methyl acetal. So part J, we want to convert benzaldehyde to benzaldehyde with an isotopically labeled oxygen, oxygen 18. We can do this by dissolving the benzaldehyde in isotopically labeled water with catalytic acid, and that will this carbonyl will go through a hydration reaction, and so by using a lot of isotopically labeled water, then the equilibrium would drive this towards the isotopically labeled carbonyl. So part K, we want to convert benzaldehyde to this benzyl alcohol, but we want to isotopically label one of these hydrogens with a deuterium. And so the way we go about doing that is to reduce this carbonyl. Instead of using sodium borohydride, we'll use sodium borodeuteride. So we replace those hydrogens with deuterium, and we'll follow that with an aqueous acidic workup and produce the this labeled product. So part L, convert benzaldehyde to this cyanohydrin We can do that with hydrogen cyanide. Part M. Convert benzaldehyde to this phenylhydrazone, and we can do that using phenylhydrazine. So part N. Oh, looks like I've got parts N and M confused. The N was to produce the phenylhydrazine, and M converts the benzaldehyde to the oxime. So we can do this using hydroxylamine, and on both parts N and M we get the stereoisomers because essentially we can have this carbon-nitrogen double bond in either the Z or E conformation, and so we can get this hydroxyl group of the oxime over here, or we could get this whole phenylhydrazine over here as well, creating the stereoisomers. So then part O, benzaldehyde, to this conjugated double bond alkenyl group. We can do this with a Wittig reaction. That our Wittig reagent would be this triphenylphosphine compound. Let me draw that a little clearer. With this carbon attached to this alkene that will react that with the carbonyl to replace this carbon-oxygen double bond with a carbon-carbon double bond and attach this alkenyl group to the where the carbonyl was. So that's it for 1633.